Welcome to this virtual training session on how to use the laser writer. This optical lithography system is located in the CGC Class 100 cleanroom and can be booked on Cluster Market. Okay, before we take a closer look at how to operate the system, here are the requirements on you as a user. You'll have to bring two things, and these are kind of obvious. Of course, you have to bring your pattern, and this design file of yours ideally has CIF format. So the file extension should be .cif. You can use the software ClearWin5 that is installed on this laser writer to convert other pattern types, such as GDS or DXF, into the CIF format. But ideally, if you want to be sure that the pattern you're going to expose is fine and there's no errors and conversion errors with that, you could bring the CIF format file. You should also make sure that the minimum feature size in this pattern is about 1 micrometer, so this concerns both the features you want to write and the gaps in between them, and this is essentially limited by the resolution of the system. On the other hand, you obviously need to bring your sample, and in most cases this would be sort of below a millimeter or so. Most ordinary silicon or silicon dioxide wafers that people are using in the CGC have a thickness of 550 micrometers, so in most cases this is not an issue. There are some exceptions to this rule, which can be essentially, for example, found in the logbook or in the handbook of the system. There's also a limit on the maximum size that your sample can have in the lateral dimensions. So 6-inch wafer is the biggest that can be loaded into the system. And ideally, this again is just sort of a rule of thumb, and especially for beginners, this might be interesting or important. If the substrate is reflective and has markers on top of it, you'll have an easier time finding the focus before you start an exposure. So experienced users can also start using transparent substrates and will struggle less when it comes to unmarked substrates. But to get started on the system, our recommendation is to use marked substrates that are reflective. Throughout this tutorial, I'm going to be referring to just this dummy pattern that I'm showing here in this image. So what you see here is the layout file. In this case, it was a GDS file, which I then converted to CIF. And you see there's 3 different layers here. And what I'm going to be showing you in this case is how to expose the red layer, so these rectangular shapes here, and how I'm going to align this with respect to these purple lines, which in my case were waveguides that already are present on the substrate. So you'll see this pattern again. Okay, besides the pattern, as I said on the second slide, you need to bring your sample. And by that I mean you have to bring a sample that already has resist on top of that. Recipes are not going to be part of this exposure because this depends on what kind of substrate you have, what kind of material you want to structure on nano pattern or so on. So this is not going to be part of this tutorial. Nonetheless, I'm going to show here a typical spin coating process. So let's start this video. So here I'm applying photoresist, having covered the spin coaters, starting the rotation, and then in the next step, once the rotation is done, I'm going to bake the sample on the hot plate. So taking it off the spinner and moving it to the hot plate, and then baking it at the required temperature for the required duration. Again, this depends highly on what kind of resist you're using. Okay, so having thought about our pattern and our substrate, we're ready to take a closer look at the actual laser writer. So what's important is you need to book the system in advance. So this, as I said before, is done on Cluster Market. And once you've used the system, you need to fill in the logbook. That's currently located here next to it on the left of the machine. To turn on the power, you are going to be looking at this front panel here. So if we take a closer look here, you will see a power on button, similar to what you would see on your PC. And you have to press this button and keep it pressed until you hear a sound, sort of a bing sound, and there will be some lights flashing up slightly above this panel. So let's have a look at this. Here you see me pressing the button, and I keep it pressed until these lights flashed up, and there would also be a sound. Once you've turned on the system, from then on onwards, you're going to be using basically this interface here, using the monitor and the keyboard. Okay, so here you see a screenshot of the desktop, which is essentially the view you would get once you've turned on the system. So this photon steer software turns on by default, starts up by default, and you also will see this JPEG file that contains some information about the username and password that currently you need to log into the system. So you can essentially copy those details here into these fields for entry, and then you're ready to go. First thing you typically want to do is import your pattern file. So for that, you should bring your pattern on a USB stick. The system is not connected to the internet. And the only important point to stress here is that this USB stick really should be free of malware. We've been advised by the manufacturer of the system that there's virtually no virus protection on this computer. So you really need to make sure that you are not corrupting the system. To plug in your USB stick, you have to open this front panel here. So on the next slide, you see this lid here closed and open. And over here, you have two USB slots where you can connect with a USB stick. Once that's done, you would copy your pattern file onto the PC. So what we've set up here is a pattern folder where everyone has their CRS ID. As a folder, if you don't have one, create one and copy your file into that. Afterwards, you can eject the USB stick and you're ready to go. So next, as you see here, I've filled in the user log and the password. At some point in the future, there might be a switch to giving people individual access with a CRS ID and a password of their choice, but that's not yet been implemented. So once you fill this in, you can click Start, and what you'll see happen is the photon steer software goes to a different window, and this warning button or this warning box pops up. And the system generally is quite good at telling you what it wants you to do and what it wants you to check. So here you see written Z initialization in progress. So essentially you're doing the calibration of the system upon first startup. And it gives you even more details. It says please verify that no substrate is loaded and that the lens holder is in the load position. So let's talk about in more detail what that means. So to understand this warning box, it's good to get familiar with how the system is actually set up. So here you see an enclosure that contains the actual mechanics of the system. So the stage where you load your sample ready for exposure is contained in this box. And over here you see this window, which you can open to get a better look. So here you see the stage. And if we remember, the thing we're about to check now is that no sample is loaded and that the lens holder is in load position. And essentially what the software means by that is you want to see that of all the available lenses in the system, and there's four of them confusingly labeled lens 2, lens 3, 4, and 5. Load position corresponds to lens 2 being the one that aligns with the center of the stage. So lens 2, as is illustrated here, is the one that's furthest away from the stage. And because during this Z initialization, the stage is going to move up and down, you just want to make sure that lens 2 is the one that is aligned to the stage. So essentially you can think of it like like this. So you want to make sure that lens 2 aligns with this. This might not be obvious to see the first time you're using the system, but once you're familiar with it, this is easy to spot, and it will be very easy to spot if lens 5 is selected, because in that case the tip of this lens is essentially very close to the stage, and it would be dangerous to do this calibration in that position. If you do find the system loaded incorrectly and lens 5 is very close to the stage, there is a way to change it by hand, because the electronic switch to change between different lenses is not available to you at that point during the calibration. So if you do want to change it by hand, there's this lever here on the left that you can push to the side, and then you can see the lenses slide backwards and forwards. Unless you're having to do this during this calibration step, it's preferable to not use this and use the electronic tool available and addressable through the software, which is sort of this pin over here, which can slide in and move the lenses backwards and forwards. You should be using that in most of the time, in most of the cases. The next thing the system is wanting you to check is virtually the same thing. So again, verify no substrate is loaded and that the lens holder is in the right position. And what it's going to do is do the X and Y initialization. So it will check that it has range in those two directions. And if the previous user made a mistake and left the system with the stage in the load position, then it will also move the stage back into the center of the enclosing chamber. Once that's done, you can click OK, and in the next instance you will click Data Management over here. What that will do is it will open another window, and this will allow you to then import the pattern file that is currently in your pattern folder over here into the internal database system that this PhotonSteer software uses. So you will click on Import, and this just opens the Windows Explorer. And in this case, I've located the pattern here, and I'll double click on it. You again see it is in the CIF format. And then you can click Open, and you will be prompted to enter your sample name and your CIS ID. And yeah, unfortunately, I forgot to take the screenshot of this, but it's pretty self-explanatory. The third thing you will be prompted for is a decision on a file archive. So this PhotonSteer software has 10 different file archives. It's just a way to sort of subgroup and organize these patterns that are being loaded onto the software. And in the CGC, we've basically come up with this archive assignment, which you can find here in the text file that is also saved on the desktop. And based on what is your status, so if you're a CDT student or an industrial visitor or so on, you will choose the archive that is most applicable to you. In my case, I think that was archive number 2, so we'll see that again. So once that's done, the next thing, okay, I lied, archive 7. Once that's done, you have to click, you have to select your file. So the button below import is select. So just having added the pattern file onto the system is not enough. You still have to select it as well. So over here, you would click, you would open the drop-down menu, select the archive in which you've saved your pattern, and then you can locate your pattern and select it. So here again, you see these two buttons, import, and once you've imported it, you need to click select here and locate your file. The pattern uses, or the software uses an internal pattern ID system, and you can cross-check that the one that you've selected corresponds to the one that is in your archive. And you will always see the currently active job, so the one that's currently been selected, listed down here. You can also take a closer look at the active job by clicking this ClearWin button, and ClearWin is another pattern software that you can either use to prepare or edit CIF files, or in fact other pattern files as well. So if I click on CIF, it will open this ClearWin software, and here you see the pattern from before. Basically you can zoom in and zoom out, which is shown here. Zooming out, for example, shows you a the pattern in the pattern coordinates of your original design with respect to this circle here, and what this circle shows you is essentially the dimension of the stage. So this should roughly correspond to a 6-inch wafer. And this should give you an idea whether you've maybe done something wrong when it came to importing the settings. So if you selected nanometer units instead of micrometer units or so on, you will see this pattern be either way too small or way too large with respect to this circle. So this is just a way to sort of sanity check that your pattern is the right size. If I zoom in, we can take a closer look at my particular pattern file here. And as I said before, I want to write this, in this case, purple layer now. It's changed color from before. And it's not a very complex pattern, just rectangles. But one thing that it's important at this point here is to decide which features are here I want to use as marker to align the layer I want to write with the layer that is already on the substrate, which in this case are these waveguide structures here. So what I'm going to pick is 2 alignment markers. So you see these rectangles here in this case, or these squares. And I'm going to select one on the left of my intended pattern position and one on the right of my intended pattern position. And I will write down the pattern locations, or their location in this pattern coordinate system. So if I zoom in further, this is, for example, what the marker on the left looked like. And this unfortunately doesn't show here because I recorded these screenshots rather than a direct screen capture. But if you read off the position here on the X and Y scale that is shown at the left and at the top of this, you can get an idea of what the position of this marker with respect to the global pattern coordinate system is. I think if you click on it, you will also see the position come up. Okay, having made a note of the positions I want to use for my alignment markers, I will leave this data management window, and you will again see here the active job with the pattern ID that my pattern has be displayed here in this top window, or part of the window. The final step before you can actually load your sample into the system is to convert this CIF file into the system internal file format, LDF, which I think stands for laser drawing format. And to do that, you have to click this Make LDF button, and it will open another window. And at this point, you would write down here for A and B the positions of your alignment markers that I basically asked you to note before. There's other functions here, so instead of like an array function, for example, or to introduce a global offset, if you want to learn more about this, I would advise you to have a look at the handbook. So here you see I've basically changed the positions of the A and B markers to what they were. I clicked Go, and then after doing this internal conversion, it will say conversion completed. You can see that this has been done by this tick that has appeared in this box next to the Make LDF file. So you don't have to do this for every layer of your pattern. It will do this conversion for all the layers in advance. And this is also true for the pattern file. So you don't have to import every layer individually. Ideally, you only create one job based on a pattern file that contains all the layers simultaneously. Okay, once you've done this, you can click Start over here, and it will open a new window. So this is the interface of the laser writer in the setting where you can actually control the system. So you can see over here, you have some sort of video feed, which in this case is still dark. And then you should be aware of this divide here. So there's a left half of the screen, the right half of the screen, and you can only have one side or the other side be active at the same time. Once you've clicked Start, by default, the left half will be active, and the very first thing you would want to do is click Unload over here. And what this does, it brings out the stage close to the window and the opening of the enclosure. And you'll be able to load your sample. So click unload. This will then trigger the movement of the stage. And as you can see here, it first slides towards you, looking through the window. And then it will move to the right until it's in its final position. The next step, you'll be placing your sample onto the stage. So here you see me using soft tip tweezers, so try to avoid using metal in order to not scratch the surface of the stage. And what I've done is I've placed the sample in the very center of this stage. There's a vacuum hole there, so try to cover the vacuum hole with your sample. And if you put it in straight, that will help. This is obviously these are optical lenses, and as you typically see on optical microscopes, the image will appear flipped. So try to put the sample in that way so that the far left or the bottom left of your center will be in the far right of the stage. So essentially put in the sample upside down and it will appear the right way up on the video feed. Here's just another photo of the sample inside the chamber. It's still hard to see. Once you've placed your sample on this vacuum hole, make sure to switch on the vacuum. This is done using the switch on the left of the computer monitor, so turn it into the on position. What this does is it will switch on the vacuum, and over here, just below the load/unload button, you see this statement, vacuum OK, and it has changed color from red to green. The next thing you want to do is to enter the thickness of your sample into this box here. So it says thick dot. So put in the thickness of your sample in micrometers and confirm it, and this is important, confirm it by pressing enter. There seems to be some sort of bug in the software, so just entering and typing in the numbers doesn't actually lock in the value. So type it in and confirm by pressing enter. You will then click load over here, and this box comes up asking you to confirm the thickness of your sample. Is the new substrate about 700 micrometers thick? You can click yes. It's important to realize that this number here is not a safety measure, so it will not stop you crashing. It will not stop you crashing the lens into the substrate. It will later on serve as a way to help us bring the surface of the substrate into focus. Once you've clicked yes, the stage will move inwards, and what should ideally happen is that you see the surface of your substrate appear on the video screen. Sometimes you might be slightly misaligned, so your sample may have moved too far, or too far, like to the back, or too far to the left or to the right, and you may have to correct the position in order to see something. Speaking about movement, so you can use the arrow keys on the keyboard, up, down, left, right, to move an X and Y. If you want to change the height of the stage, so move it closer or further away from the lens, which is fixed in space, you can use page up or page down. So page up and page down changes Z, the arrow keys left, right, up and down change the X and Y values respectively. So in this case here, you've seen me move the field of view to the edge of the sample, which can help with focusing. It's the same reason why it's easier to do lithography using the laser writer on a marked substrate, because it allows you to find good focus. So having something to focus on helps a great deal. The first thing you would typically want to do is find a marker. So in this case, if I show you the highlighter here, This is the marker I want to use for alignment, or at least one of them. So I've located this marker now, and the next thing I want to do is go from the current lens, which is lens 2 here, the one that had the greatest focal distance and is furthest away from the substrate. And this should be used when you load in the sample because it's the safest one. So I want to go from this lens down to the lens that I want to use for the exposure, which in this case is lens number 5, which offers the greatest focal, the greatest resolution, but is also closest to the substrate. So the challenge is, how do you go from what appears to be roughly in focus in lens number 2 to what down to lens 5 and still stay in focus? And one feature that is quite good to use for that is to compare the Z readout, which is shown over here, along with the X and Y readout of the position, with the calculated position based on this thickness value over here. So if you click Set Z, it can update the stage height, so the Z position, basically based on what the system considers to be best focus on, based on this number you've given it here. So typically what I do is I find best focus by hand, so by hand and by eye, using the page up and page down button to change the height position, and by how much I change it is sort of given over here. If you see Z step, that basically tells you how much you are changing the Z position for every page up or page down click. Similarly, the X and Y step shows you how much you're moving up or down while you click these arrow keys. You can move in different speeds, which you can adjust over here, and at any time you can stop the movement by clicking the spacebar. So let's dive into detail. Let's look into more detail into this setting the best focus condition. Okay, let's take a closer look at this concept of setting the focus or adjusting the height position on lens number 3. So I've switched to the next highest lens by clicking 3, and then it takes about 10 seconds or so. You will see a little cursor appear, and it switches the lens for you. So what I typically do is I click Set Z. I'm fairly confident about this value of 700 here, or at least I'm confident enough to know it will not be crashing the lens if I click Set Z over here. And what this does, it basically goes to the calculated position where it thinks the best focus is. I would then, starting at that value, and I keep a close look at basically the current Z position over here, I would then update the focus by hand by clicking page up and page down again until I find the best focus, until I find what I consider to be best focus. So I've done that over here, for example. So you see the Z position has changed accordingly. And then what I typically like to do is feedback this information. So the difference in Z readout between what the system thinks the best focus is based on the previous thickness value, and what I think to be best focus, or what I consider to be best focus. And then I update the thickness value based on this difference. So the calculated position and what I consider to be the position displayed here, the difference was 70 micrometer in one direction, obviously. And so I've updated this thickness value to 770. And typically what I like to do is, as I go down on the lenses from 2 to 5, I continuously update this thickness value so that by the time I get to lens 5, I'm pretty confident that this is the most accurate value. And by clicking Set Z, so by going to the calculated position of best focus, I should be getting pretty close to the real thing. And this will allow me to find focus more easily on lens number 5, where the focusing window is quite narrow. So you have to get it right within a few micron, this Z value, otherwise you'll be out of focus. So here I show the same thing again on lens 4. zooming in further onto the marker I want to use for alignment, so to say. And I've again updated the thickness value slightly to get closer to what I consider to be the real value of this chip. Besides using your eye and some particles of dust or a feature on your substrate, you can also use this blade, which is a blade that has been installed in the sort of optical beam path. And the way this has been set up is that this blade over here is roughly in focus when the surface is in focus. So this is sort of a second tool that you can use to find best focusing conditions. Okay, so I've now switched to lens 5. The thickness value, or sorry, not the thickness, the Z value is the same as before. And you see that the video feed has suddenly gone all black, which means that you're very far out of focus and sort of speaks for this different nature of lens 5. And at this point, just using the page up or page down button, you don't really know whether you have to go up or whether you have to go down. So at this point, this set Z function comes in quite handy. I've optimized this thickness value on the previous 3 lenses, so I'm fairly confident about this value. I'm going to click it, and what you see happening is the following. This warning message pops up, and this warning message pops up whenever you're about to move the stage closer to the lens, and it's asking you to confirm the thickness value, because I've double checked it on the lower lenses where the distance between the lens and the stage is greater. I trust this value, and I can click yes. It's asking me even for a second time to confirm that this is a sensible value. By stating the substrate is to move toward the lens, please check that no damage occurs. I trust this value though, so I click OK. And what this does is basically it gets me much closer to the real value that is appropriate for lens 5. So you can see basically the screen has turned bright again, and I can see my alignment marker here. I can see the outlines of it, even though it's still a little bit out of focus. By the time you've gotten to lens 5, it has updated these default X and Y step values and Z step values. So now every time you click page up or page down, for example, you're only changing the Z position by 1 micrometer. And then proceed to find the best focus condition using the page up and page down key. So continuously updating the Z position here, the Z readout, until I'm happy. The challenge for the exposure is that the surface might not be perfectly flat of your substrate, but you would like to stay in focus throughout the exposure without having to monitor it constantly manually by hand, so to say. There's 2 options available for you by default. One of them is called the ring focus method. The other one basically uses plane focus. Plane focus is a little bit more intuitive to understand. So what you could do is you find focus in 3 different positions on your chip, ideally at sort of opposite corners of your substrate, and you find the focus manually by adjusting the page up and page down position. And you save these 3 focus values in these values M1, M2, M3. And then it can use those 3 values to calculate a focus map throughout across the substrate. So similar like you'd have an algebra. Basically, you need 3 points to define a plane. This is essentially what it's using here. So you're defining these 3 points by going to 3 different positions on your zip, focusing 3 times, and then clicking set M1, set M2, set M3. And later on, you can then use those points to calculate this focus map. The other option available to you is to use an interferometer that tracks the height of the surface by bouncing parts of the lights off the surface and creating an interference pattern that can be assessed and used for height tracking. To calibrate this interference pattern, what I like to do is I move upwards. I mean, in this case, upwards to be in a region where I have nothing disturbing my interference pattern, but I'm close enough to my original feature to know that I should still be in focus, even if I don't see anything on a screen that is all the same color. So here you basically see the very edge of the alignment marker I want to use, and I'm focusing here on a smooth part of the chip. I then clicked Cal for calibration over here, and this opens this box here asking me whether I found the best focus condition using thin surface defects, so I guess any feature on the surface or the blade. So this is this black line here I mentioned before. Upon confirming that, it will show you this interference pattern, and you can adjust this interference pattern using these features over here, brightness, contrast, and light, until this pattern is traced out in a nicer way. And what will then happen once you click save over here is, this unfortunately again couldn't capture with the screenshot, it will have box come in from the left and from the right, and it will measure the diameter of this interference pattern this way. So here you see basically the optimized pattern. I would then click save, and it would measure the radius or the diameter of this interference pattern. And then what happens is, as you scan over the surface of the substrate, if there's a height difference or a change in the height or in the distance between the lens and the surface, this interference pattern will change. So it will either become narrower or wider, and then the system will update this and try to recreate this pattern and maintain the same radius of the of this interference pattern to make sure you stay in the same focusing conditions. Once the focusing has been sorted, it's time to set the alignment markers, and this will come up down here. Before you can do that though, and in this case I've taken the screenshot when this was already done, you need to reset the a second interferometer, which is used for X and Y tracking. And you do that by going to the 0, 0 position in the in the electronic readout of the system. So you go to the 0, 0 stage position by clicking 0, 0 over here, and then clicking reset. And this will basically also set these X and Y values for the interferometer, and basically make sure those match up with the other values over here. You would then return to the alignment marker, and basically align on the feature whose coordinates you entered when you created the LDF file. And to do this, to get this alignment really precisely, what you can do is click first mark over here, and it will open this red crosshair, and then align the red crosshair position basically with the position I used for my alignment marker. It's then asking me to confirm this choice, so I click OK, and then what you will see is that this alignment marker has been turned green. So here you see the X and Y position of the pattern written out again, and now this has been switched over to green. Vice versa, I would then go find the alignment marker by using the arrow keys. On the other side of my chip, again, I can find the best focus either using my eye or using the ring calibration feature that I've set up before. So to basically get this interference pattern come up on your screen, you can click auto, and it will then basically match the interference ring diameter to adjust the focus accordingly. So then I again set the crosshair position to the feature that I'm aligning to. If you want to get it really right, you can use right click while this red crosshair is visible, and it will basically move the center of this crosshair to where you right clicked. So it will then again ask me to confirm the position, and then once I have my markers A and B set up, they're both green down here. Okay, once the alignment markers have been set, you are in principle ready to go. So here I also just sort of to show you what the alternative to the ring focus would look like. I've also set the M1, M2, M3 focusing conditions. But so basically, once you've sorted out how you want to stay in focus during the exposure and how you want to align your pattern to the substrate, you are in principle ready to start the exposure. One more thing you need to set basically over here on this left side is, or actually two more things. You need to click match, and this will update the right settings of the system to the lens you're currently on. So right now you see it's got lens 3 written here, but I want to do the exposure on lens 5. So now it's switched over to lens 5. Here you can see that. So the right settings have been updated to the current lens. And then the other thing you want to do is to essentially apply the parameters for your exposure. And again, this depends on your specific resist and the lens you're using. And in this specific case, I was using the 3% filter. So there's some sort of optical filter or various optical filters to choose from. And this can reduce the power of the laser along with some other settings. And my resist parameters required me to use this 3% filter. So once I've worried about all of this, so I've reset the interferometer, I've set the alignment markers, I've thought about how I want to stay in focus, I've matched the lens, I've set the right filtering conditions. I can then click on this arrow key, and then this will deselect everything that's on the left half here, and it will take me to the menu available on the right half. So the first thing you'll see is it shows me the pattern from the pattern file for a given layer. So in this drop-down layer, you can select the layer that you want to expose. Sort of just reiterating this point that you don't have to import every layer you'd possibly want to do one by one, but you can select them and import them all at once and then just select them at a later point here. In my case, I wanted to write this layer number 1 here though, so I didn't update this. It will give you some more information. Again, here it displays the active job, so this is nothing new. It will give you the size of your pattern, and over here you can select the alignment options. So here I'm going to select in a second that I want to use these A and B markers. Here I can select which type of focusing I want to use, so I'm going to switch it from plane to rings in a second. And then two other parameters that depend on your specific resist and the lens and the type of process you want to do are the exposure gain and the D-step. And what this D-step does is it is a measure of how much successive line scans of the writing unit overlap with one each other. So if there's more overlap, this will increase the effective dose. And it comes up with a calculated value for the effective dose in millijoule per square centimeter, and that's displayed here. So now if I click, you'll see all the parameters I just mentioned updated to what I want. So here I want to use the A and B markers, ring feature, and for this particular resist and lens, I'm using these settings. Once I've set all of this, I'm pretty much ready to go. So I would click go, and based on the settings that I've applied, it will, in this case, ask me to confirm the settings of the ring focus method. So I'm still happy with these brightness and settings and so on. So I would click yes, and then in the next instance, it's asking me to confirm the current layer. So is this actually the layer I want to write? In this case, yes. And then I would be able to click yes, and it will start the exposure. So it will move the stage to start the exposure at the top left of this pattern. One thing I forgot to mention here, if you select bidirectional strip, it will do the exposure sort of in this manner. So it will start at top left, go down, and then the next line of the pattern it will write by going from the bottom to the top. And the entire pattern is made up of these strips, so it will break this bigger pattern into these strips, and you see how many strips are there in total. In this case, it's 23. The black lines here indicate the progress. So when this screenshot was taken, basically it was in the process of writing the first strip and had gotten about halfway through it. Once the entire pattern is written, you will see that the red cross that marks the stage position is at the right side of the pattern. Everything is covered in these black lines, meaning all of these strips have been written, and we'll switch the ring focus method back off, and you'll start to see the optical video feed again. At that point, you're essentially done, so you can click this arrow over here to go back to the other side, which enables the control features. So these arrows will change colors again. At that point, you would want to switch from lens 5 back to lens 2. And once that's done, you click unload. It will remind you to switch off the vacuum pump. So you click OK, and then basically it will move the stage back to the front of the chamber, and you can take the sample out. So again, I'll be using the same tweezers without metal. I'll take off the sample very gently, and I'm ready to develop my pattern. Again, this is highly dependent on what type of recipe you use. Here you see me take the sample out of the developer into a liquid that stops the development, and then the lithography is done essentially. So of course I can dry off the sample as well. And once that's done, of course there's the possibility to load the sample back inside and have a look at the pattern that you exposed. So I went through the same steps of loading the sample, and you can see me inspecting the pattern here on lens 2. Once you've then taken the sample off the stage and moved the stage back into the center of the chamber using the load command, you can click exit at the bottom of the previous screen, and it will take you back to this particular screen of the Photon Steer software. You can click exit again, and then you just switch off the system like you switch off any other Windows computer. Okay, that brings us to the end of this virtual training session. The next step will be to arrange a hands-on training session with you.